Hello everyone, welcome back to this SEO training program. In this video, I'll be explaining my solution for a clever brute force problem, which is taken from the Atcoder beginner contest. And this problem is not exactly a typical SEO style problem, but it includes an important idea of some types of creative brute force solutions which you may be expected to come up with in the contest. So this is not a standard bitmask type of brute force which shows up in subtasks in ZCO. This is a more open-ended type of problem. So you should try to get comfort in solving ad hoc brute force problems as well, because they may show up for a small number of subtasks in the actual contest. So in this problem, we are basically given an XY coordinate plane, and we need to check whether there is a lattice point whose distance from two other points are both square root of 5. So we need to check whether any such point exists such that the distance from that point x comma y to the points x1, y1 and x2, y2, if both the distances are exactly square root 5. And this is the formula for the distance between 2 points. So the values of x1, x2, y1, y2 are up to 10 power of 9 plus minus 10 power of 9. So we can't obviously brute force over all possible values in the xy plane. We need to think about cleverly. We need to cleverly think about this condition of the distance to be exactly square root of 5. And obviously there is no direct math solution. We need to manually check a number of close points. So we need to check points which are close enough to both these two values of x1, y1 and x2, y2. So let's understand which values of x comma y are possible candidates for this condition to be met. First, let's write down the condition which is asked in the problem statement. Let's say that the 2 points which are given in the input are x1, y1 and x2, y2. And let's say that the answer point is x comma y and the answer is x comma y. Let's try to write down the condition. So the condition is that x minus x1 squared plus y minus y1 squared should be equal to 5, because the distance is square root of 5. So when you take the square root of both sides and you square that, you get this condition that the sum of these two squares should be 5, and also the sum of these two squares, x minus x2 squares plus y minus y2 squared, should also be equal to 5. So we need to ensure both these conditions are met. And from this problem statement itself, we realize that the values of x are actually quite limited. The values of x and y are quite limited. We know that if the difference, if x minus x1 is very big, if it's something like 10 for example, then 10 square will be 100, and you cannot get a possible value of y minus y1 so that 100 plus y minus y1 squared is 5. It's not possible, obviously, because the square values is non-negative, it's 0 or a positive number. That's why we know that the value of x minus x1 squared, so this value is going to be less than or equal to 5, and for simplicity we can just take it to be less than or equal to 9, because 9 is a square number and we can take the square root of both sides. And this means that we can easily just limit the value of x minus x1. So the difference between x minus x1, the absolute value of the difference, that is less than or equal to 3. And this means that there are essentially only 6 possibilities of x. The 6 possibilities of x are x1 minus 3, x1 minus 2, x minus 1 and x1, then x1 plus 3, x1 plus 2, x1 plus 1 and x1 again. So we know that x1 minus 3 and x1 plus 3 are not possible, because the difference will be 3 squared, which is 9. So it's actually only these 5 possibilities for what x1 can be, and similarly there are only 5 possibilities for what y1 can be, because by similar logic we can see that the difference between y1 and y is at most square root of 5. So that's why we know that x and y are integers. So that's why we can just see that they will be only these possibilities for x1 and y1, and we can brute force on these 5 possibilities for x1. For each of these 5 possibilities for x1 and for each of these 5 possibilities for y1, we will manually check whether the sum of the distances, whether the sum of the squares is 5 for both the points. So for each value of x1 going from this point, going from x1 minus 2 till x1 plus 2, and for each value of y going from y1 minus 2 till y1 plus 2, if the sum of the squares for both these quantities is 5, then we'll print x comma y and we'll break. Otherwise, if we get no solution for numbers in this range, then we'll print no, because we know that from the conditions of the problem statement itself, the value of x minus x1 and the value of y minus y1 can be at most square root of 5. And now I'll just show you the code which implements the exact same complete search idea. So in the code, for each value of x going from x1 minus 2 till x1 plus 2, we will again go through each value of y from y1 minus 2 till y1 plus 2. And if the sum of the squares, so another way to write this is, if y minus y1 into, you don't need to put absolute value, you can just do y minus y1 into y minus y1 plus x minus x1 into x minus x1, if that is 5, and y minus y2 squared plus x minus x2 squared, if that is also 5, we'll print yes, otherwise we'll print no. And you can verify that this code gets accepted. So I hope you like this little brute force idea, which is actually quite simple, but it's important for you to realize that something like this can show up as a small subtask in ZCO. And if you have any suggestions or doubts or comments, do leave them in the comment section down below. Thank you. With this problem, we come to the end of week 1, in which we discussed complete search techniques mainly and a bit of ad hoc implementation. In the second week, I'll be explaining sorting, searching, and greedy algorithms, including recursive type of sorting, which is merge sort, and some variations of merge sort. In the second week, we will look at more interesting problems using these techniques. So stay tuned to the upcoming videos in the ZCO playlist.